Hi, this is Mrs. Vrobel. This is Chapter 11, Stoichiometry, Part 1. Now, most students, when they hear this chapter, they kind of scratch their heads and they're not exactly sure what this is all about. So I thought I'd show you this picture. What is a chemist's favorite plant? Stoichiometry. In all seriousness, no, it's not about a tree. It's about something else. So when you hear the term stoichiometry, there's a couple things you need to keep in mind. The first thing is this is a quantitative relationship. So remember I talked about the mole in a previous chapter? The mole is essentially quantifying matter. And now we're going to look at what is the difference between reactants and products in a chemical reaction. And secondly, with stoichiometry, we're looking at how do we calculate quantities based on the amount of reactants or the amount of products in a chemical reaction? So you're going to get really good at converting reactants to products or products to reactants. And in everyday life, if you're working for a chemical company, maybe a pharmaceutical company, it's really important for them to know if we have so much of a reactant, how much product are we going to get out of that material? If you're in the food industry, you want to know that. And stoichiometry is the tool that chemists use to help quantify matter when we're going between reactants and products. Now, with stoichiometry, there's a certain methodology or a certain way that you want to solve problems. So the first thing that you need to do with any stoichiometry problem is make sure you read the problem. This is key. You want to identify what do you know, what don't you know. So you're going to look for the known first, and then after you look for the known, you're going to look for the unknown. And we'll practice this in class. Third is very important. If you do not know how to write the chemical equation, you are not going to get the answer that you intended. So we need to review nomenclature and we need to know crisscross with ionic compounds. And this is so important, balancing the equation. If you don't balance it, you're going to get the wrong answer. And obviously, we've practiced plenty of that. And then lastly, do the math. So you're essentially converting, using units, cancel things out so that you arrive at the destination you want to arrive at. Okay, so here's a flow chart. And essentially what you need to do is you take your given or your known and you want to convert it to moles of that given. So if you're starting out with a reactant and they give you mass, you're going to convert the mass to moles. Then you're going to look for the relationship between the moles of reactant and the moles of the product. And the way you do that is you look at the coefficients of each. And we will practice that in class. And then after you've determined the moles of the unknown, you essentially can get your desired unit. It may be mass, it may be moles. Now, I will give you copies of this. This is what I call my mole machine. It's really, really helpful for a lot of students to understand what's going on here. Now notice on the left-hand side of this mole machine, we could be talking about volume. And anytime you're talking about volume, talking about a gas, that gas, we're going to use this constant here, which is 22.4 liters per mole. So if you're looking at a gas, that is just an automatic constant for gases. If you're talking about mass, notice that we could either divide by molar mass or we could divide by Avogadro's number. So if we want to get moles, we're going to divide by molar mass, and that'll give us moles. If we don't want moles, we're going to divide by Avogadro's number to get molecules. Now, if you look on the right-hand side of the machine, if you have moles in the middle here, notice you're going to multiply by that constant that I was talking about for gas, and that'll give you volume. If you're not interested in that, maybe you just want mass. So you take the moles and you multiply by a molar mass of that compound, and that'll give you mass. If you don't want that, maybe you're going to get Avogadro's number and convert the moles to molecules or atoms or particles. So like I said, this is a really key piece for understanding the process with stoichiometry.